All right, so we got chapter 1, section 4, measuring and classifying angles. So we're going to talk about angles now. And you probably dealt a little bit with angles. You've heard of acute angles, obtuse angles, right angles. I know because my son's only in 5th grade and he has done a lot of the exact same things that we are going over here, but we're going into them at a much deeper level. So, angles. So an angle is formed by two rays that have the same endpoint. If you look down below, you can see an angle, that one that has P, N, and O on there. There are two rays. They both start at N, and they go off in different directions. They are not lines going in different directions. They're just, this basic angle here is just two rays. There's a ray going from N to P, there's ray NP, and there's ray NO that form this angle. Those rays we call the sides of the angle. So, for example, I'll do them in red and blue here. One of the sides of this angle is ray NP, and one of the sides of this angle is ray NO. Two sides of an angle. That common point, the thing that those rays have in common, is this point N, which we call the vertex. It is the vertex of an angle. Where those two lines meet is the vertex, and it is the most important part of this angle. It helps us name it. When there is only one single letter, there are three ways to name it. We can name it by its vertex, so it is totally okay. You're going to see this symbol, by the way. This symbol over here means angle. So we could call this angle N because that is the name of the vertex. You cannot call it by any other single letter. You can't call this angle P, you can't call it angle O, but you could call it angle N because N tells me that that's the vertex. So it's only one single angle there. And what I mean by that is this. There's nothing on the other side. Like we could have an angle that looked like this going off here. Then we can no longer call that angle N because there's like two angles stuck together. So we cannot name it that way unless it's only one angle we're looking at, which is exactly what we see here, just one angle. Now, the other ways you can name it is that you can name it with three letters. And you can choose to go this way, angle PNO, or you can choose to go the other way, angle ONP. But the one thing that has to stay the same is that N, if you're using three letters, N has to be in the middle because N is the vertex. When you write three letters, what I know is the letter that is in the middle, that's the vertex every single time. So we could even call this a number. So let's pretend that those letters are not there. So in your mind, imagine P, N, and O. There's another way. I could just have this as angle 1. Sometimes you'll see them with just numbers in there. Angle 1, angle 2, angle 3, angle 4. But in this case, we could call it angle PNO. We could call it angle ONP. You could not call this angle NPO. Because if I called it angle NPO, the P is in the middle, and it says the vertex is somewhere else. Question so far? Because if we got this, then this is like, we're golden. Like this is...
Nice one a bit up.
Oh, sorry. Yep, I'm a little off the screen there. What would be most difficult about this is that if I asked you to name this, and here is where a lot of people are going to be unhappy with their quiz grade, is that notice it says angle PNO and it has that symbol. If I asked you to give this angle a name and you only wrote the three letters, it would be incorrect. Because I don't know whether that's a line, I don't know whether that's a plane, I don't know what that is unless you draw the little angle symbol in front of it. It doesn't have to be perfect, it looks like a little less than symbol. So we've got an angle, PNO. Make sure that's in front because that's the difference between a right and wrong answer. It is very important because it indicates what it is. It may not seem very big now, but we're going to learn so many different things that involve letters that we need to know what kind of thing is it. It's an angle. All right, so we're going to talk about naming an angle. And if you notice, there are two angles stuck together in this case. One of them is right here, just in case you can't see it. Here's one of them. And here is another one stuck right to it. And those people who are really astute will say, isn't there a third angle? And I would say, yes, there is. There's a third one, which is right here, the big one too. So there's a big angle with like two angles inside of it. There's really three different angles we're looking at there. So here's a problem. When we get to naming angles, if there are angles stuck together, we are no longer allowed to just name it by the vertex. You can't do it anymore. Because if I say angle B, if I were to write this, I don't know whether you're talking about the little one on top, the bigger one on bottom, or the whole big thing together, it is unclear. So that is not a way we can name it. But let's go back and look at that red angle I drew. So just look at those red lines for a minute. I'm going to zoom in here. Just look at those red lines there. If I wanted to just name that red angle there, what are some things I could call the red angle? Remember, I can't use a single letter before you throw yourself under the bus that way. Yes, ma'am? I can call the red, I'm going to use red here, I can call the red one angle A, B, D. There's another name I can call the red angle. Yes, ma'am? DBA. Angle DBA. Those are both perfectly acceptable names for that. Notice that I put the angle in front. Without that angle in front, without that symbol, it's very difficult to understand what you're talking about. Okay, so that's cool. So we've got angle ABD and angle DBA, and we understand that the vertex of that angle is whatever the middle letter is. So when we're talking about that, the vertex of that angle is B. Let's go on to the green one. Give me two names for the green one. Yes, sir.
BBC.
Angle D, oops, sorry, that's not a D. Angle DBC. Notice, start at D, imagine it's a road map. Start at D, go to B, and then B to C. What's another name for the green one?
DBC.
DBC is the one we just did. We just wrote CBD. Just the backwards version of that. And last but not least, let's do two names for the blue one. Yes, sir.
CBA.
Okay, angle CBA, going from the bottom to the center to the other side. And the other name for that same angle? Yes, sir?
ABC.
Angle ABC. So it's really only three angles there, but there's 6 different names because each angle those aren't like separate angles. There's one red angle that could be named 2 ways, one blue angle that could be named 2 ways, and one green angle that could be named 2 ways. You can use whatever colors you want. I just did that to differentiate. You'll see that I use a lot of colors in there. It's one of the reasons I keep the colored pencils back here, because you'll see that if you start doing it too, when you start taking tests, you're going to be like, oh, I'm going to grab some colored pencils because it helps me separate these things. I see exactly what I'm looking at, and I can name them very easily.
Where do you keep my colored pencils?
Right back there on the back wall by the pencils right next to them. You're always welcome to any of that stuff if you want it. Yep. Okay, so a protractor. A protractor is one of those tools that we're not going to use a lot here because we do everything digitally, but just so you know, you probably owned one in school at one point, and maybe you used it, but I have found that the most people who come in, like, they tried to pretend it was some sort of like thing that they wrapped around their knuckles and pretended to punch people, whatever it was. But it's some little plastic thing that usually broke in your backpack and never got used, even though the teacher told you you had to have it for that class, and you never actually took it out of the package. I know that because I have a kid who has one still in the package. It kind of annoys me. So anyway, it looks something like this, and it helps you measure angles. So the angles are measured in degrees. You've probably seen that before. We know like something that could be 90 degrees with that little symbol there. Maybe it could be 47 degrees. It could be 173 degrees. It could be 1 degree. They're all just measures of an angle. The more open that angle is, like Pac-Man's mouth, the more that it opens, the larger the degree. So angles are measured in degrees. We refer to them as degrees. So we've got 4 different angles that we're going to kind of talk about here. An acute angle. An acute angle is any angle that is between 0 and 90 degrees. Between them. It's not including 0 and not including 90. It's something that is in between them. And they are the ones that, so let's go immediately. Let's actually start on the right angle, because a right angle, if we're going to keep talking about 90 degrees, we should make sure that we understand that. A 90-degree angle is one that is going like up and down and left and right. But most importantly, I'm not sure that is a right angle unless something is drawn in there. What do we usually draw in there?
The box.
A little box. That little box, no matter what, is your guarantee that this is a right angle. It means this is definitely 90 degrees. In case, I'm sure you've seen this before, but this is a little refresher. That's a right angle. Now, it doesn't have to be facing that way. It could be facing this way. It could be facing downward. It could even be at a weird angle. It could be like this. If you see that box, that means that's 90 degrees. It doesn't matter which way you rotate it, it's still 90 degrees. Now, one angle that is less than that, if you were to close that Pac-Man's mouth here, notice I'm drawing the arrows at the ends because they're rays. We learned that they were rays. I'm not leaving those off. That's part of it. Any angle, and you'll see this line used to indicate that there's an angle there, that angle, if it is less than 90 degrees, we will say that it's an acute angle. Again, little tiny angles, they're so acute. They're the tiny ones. So anything that's like cute little ducklings, little tiny ones, they're cute. Now, our obtuse angles are any ones that are larger than 90 degrees, but less than 180 degrees. So there are big angles. There's the ones that are open more than 90 degrees, and that one might look like this. So let's say that it's maybe something like this. That's open pretty big there. That angle is pretty big. It is more than 90 degrees. I couldn't tell you what the measure of that is. I don't know because there's not... All right, so an obtuse angle is any angle that is more than 90 degrees, but it's less than 180. And then finally we get these things that are straight angles. And straight angles are usually the ones that throw people off the most, even though they're kind of like the easiest. A straight angle are opposite rays. Remember we talked about opposite rays, like here is J, K, and here is J, I don't know, L. So those are opposite rays. This is a straight angle because if I were to open it up this much, that is half a circle or 180 degrees. So a straight angle means it is a straight line that is 180 degrees. So if I ask you about that angle is 180 degrees. I don't care whether we're talking about top or bottom, it's 180 degrees no matter what. Anytime you see a straight line on both sides of that. Now, what could I call that angle right there? Give me 3 names for that angle right there. Yes, ma'am.
LJK.
So angle LJK is one. Sir.
Angle KJL.
KJL. And another one. Yes, ma'am? Angle J. Notice there's only like that one angle there. Whether we're talking about top or bottom, it's the same angle, so there we're just angle J. There's not 2 things stuck together there. So we can call that angle J. Even if someone is like, well, are you talking about the top or bottom? It doesn't matter. It's the same amount. It's the same exact thing there. But these would be the much better names there either way, because we know exactly what we're talking about. Angle J is just as perfectly acceptable, but sometimes people like to use the 3 letters because when they get mixed up in things, it becomes much clearer. It's always a safer bet to go with 3 letters than 1 letter, but you'll see that 1 letter is used sometimes too. But you're always safer bet. If you're confused, if you're like, I don't know what to do, use 3 letters. It's always safer that way. Questions so far? All right, so that protractor, if you've never used one, and we're not going to actually use one much in here, but there might be things in homeworks that talk about how to read them. So here's how you would read them if so. Like, let's say that you've got an angle. Now, this is what would happen if you actually had one in front of you. So let's say that I wanted to measure this angle right there. I've got it drawn on paper, and I wanted to measure this angle. So I'm going to put my protractor on it. Now, I'm going to do my best to draw a protractor and make this as believable as possible. And let's go. So 90 degrees would be right up here. 180 degrees would be right here. Here would be 0 degrees. There would be 45 in between. Sorry, that's not a 1 there. That's just 90 degrees. And then like 135 degrees here. So what I would do then is if I was actually trying to measure this is I would go, let's see if I can move this. I didn't mean to copy that. Can I move that? Is I would lay it directly on the thing. There's usually a little hole right down here. And I could measure this angle to see how much it is. I line it up with 0 degrees there, and I see that it's a little more than 45 degrees. So maybe like 48 degrees, 50 degrees, somewhere in there. It gives me an idea of how big this is. The more I open that, the more degrees that I see there. So if you've never used one before, that's how they work. All right. So actually, I didn't even know this was on the next slide. This is a much better protractor. You can see it there, and we can see. So this is postulate number 3, the protractor postulate. We learned the ruler postulate that says like everything matches up 1-to-1, numbers and letters. Well, The protractor postulate says, consider line OB. So we've got right here, OB right here. We're talking about this. And a point A on one side of OB. The rays of OA and OB, so we've got OA and OB. These two rays, so I'm going to clean that up, make it a little nicer. The rays can be matched 1-to-1 with degrees in real numbers. Now, if you notice, the numbers go in two different directions. Over here, they go 0, 10, 20, 30, 40, 50, 60, blah, 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 all the way up to 180. And then on the other side right here, they go 10, 20, 30, 40, blah, 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 blah. So how do I know which number to use? That's the hard thing. Well, if you think about it like this, I started right here. I made it flat with 0 degrees. And then, like Pac-Man's mouth, it opened up, all the way till it went that way. So we went 0, 10, 20, 30, 40, 50, 60, 70, 80, 90, 10, 11, till we got to 140. This would be a 140-degree angle. The reason we wouldn't measure it the other way is because we didn't start at 0. We want to be able to count up from 0 to how many degrees. And if you notice right here, it started at 0 and opened up. It's like the more you open, imagine a pair of scissors. You can open those scissors up and increase the angle. You close the scissors and it decreases the angle. Questions on that? Again, I'm not going to ask you to buy a protractor. I'm not even going to ask you to use a protractor, but I could draw something on a test like this. I could paste this on a test and ask you to tell me how many degrees that is. And you'd probably be like, well, is it 40 or 140? That's a big difference, two totally different degrees. It's not both. It's one or the other. In this case, I should feel like, well, wait, that's a big angle. It's obtuse. And since it's obtuse, it must be more than 90. So at least that helps me out. That I go, oh, okay, well, it can't be less than 90. Yes, sir.
Wait, so do you always use the number on the bottom, or it depends on like?
So you could do another one, like you could start on the other side. So let's see, and I'm going to erase this in a second, but like, let's say that I had an angle that went the other direction. Like here, I started at 0, and maybe it goes this direction. That's 140 degrees as well because I started here at 0 and went 10, 20, 30, 40, 50, all the way to 140.
So it's just one going that way.
Right. It's just which way is easier to line it up on 0. If the angle is kind of like eating something on the right, like if you want to call it like Pac-Man's mouth, if it's eating something on the right, I'll use the 0 on the right. If it's eating something on the left, I use the 0 on the left. So I can use it either way and just rotate my protractor to match it up. All right. This super important. It's just as important as the one where I walked across the room. For those of you who are falling asleep on me, this is called the angle addition postulate. And I told you that the segment addition postulate is sometimes called the SAP. Well, this is sometimes called the AAP. It is the angle addition postulate. And it says, I'm going to do the nerd speak first, and then I'm going to get into the real version that you guys will understand. Just like when I walked across the room, you'll get it. Especially if you've been to Cheesecake Factory, you're about to get this. I love Cheesecake Factory. Actually, I just think their food is just okay, but their cheesecake, oh boy. All right, so it says, if point B is in the interior of angle AOC. So let me just translate that from nerd speak. Here is angle AOC. They're talking about this, AOC. They just told me angle AOC. If point B is in the interior, it means it is somewhere inside that little chomping mouth there. So that red mouth is about to eat that piece. It's somewhere in there. That means it's in the interior. Anywhere that's not in between those two lines is considered the exterior. So if point B is in the interior, notice that we get like this line right here. And it says that the measure, now I'm going to do some color coding here, and I recommend you do the same. It says that the measure of angle AOB, now watch, I'm going to trace it. Here's angle AOB. If I were to take that and add it to BOC, here's BOC. If I were to add those two things together, those two together would be exactly the same as the big angle. Now, if you're like, wait, that doesn't make sense. Okay, so here's where I talk about the Cheesecake Factory. I have a wife, and my wife is amazing woman, best woman I've ever met in my life. But I'll tell you what annoys me about her is that whenever I order something, she always says she doesn't want something. I'm like, hey, do you want a piece of cheesecake? And she's like, no, I don't want a piece of cheesecake. And I was like, okay, because I'm going to order a piece of cheesecake. So if you want a piece of cheesecake, you should order one too, because we're about to stay here and eat some cheesecake, right? So she's like, no, I'm good. So I order cheesecake. And I grew up in a family where I don't want anyone stealing anything from me. I'm like, this is my cheesecake. I just want to eat this all by myself. I'm not good at sharing. So I just want it to myself. And then it comes, and my wife immediately pulls out her fork and tries to eat from my plate. This drives me crazy. If we ever become like hang out friends in like the future, like 20 years from now when you bring your kids and we're hanging out, please don't ever try to eat off my plate. I become like a wolf and I'll stab you in the hand. So here's what I'm saying is that if you've got a piece of big cheesecake right there, right? If you've got a piece of big cheesecake and you decided to split it into two pieces, whether it be like one little piece or two even pieces, you're just splitting it up. If I was splitting with my son, he's a little guy. He doesn't need as much as me. Look at me. I eat a lot. Like I'm going to eat a much bigger piece than he is. He doesn't need that much. So for him, I might cut a little piece and leave the bigger piece for me. So even if I were to separate that piece of cheesecake into two pieces, and put one on one plate and one on the other, there's still the same amount of cheesecake, right? I mean, it's not the same, like, I just in two pieces now. Like, it's like a pizza. You split it up, there's still the same amount of pizza, it's just split up. That's the same way with these angles. If you were to take those two pieces of cheesecake and you could re-merge them back together, the first angle plus the second angle when stuck back together will equal the big angle. And that's what you're seeing right here. That little blue piece of cheesecake and the little green piece of cheesecake there, if you stuck them back together, those angles, you stuck them back together, it would equal the big red angle there. And that's what the angle addition postulate says, is that if you've got two things and you stick them together, you will get the bigger one. And here's how that works with numbers. So let's say that this is 30 degrees. It's a 30-degree angle. I'm just making up some numbers. If that's 30 degrees, and this is 55 degrees. So one of the angles is 30, one of the angles is 55. Imagine I'm going to stick those two pieces of cheesecake together. How big do you think this angle is? How much? 85, you're right. I took the 30 and I smushed it right into, if this one right here is 55 and this one right here is 30, well then it must be 30 plus 55 or 85 degrees all in total right there. That's what the angle addition postulate says, is that those two pieces, if you put them back together, would make up the big one. And that's what you're looking at here, is that if you were to take the two smaller angles and, that's not a highlighter, if you were to take the two angles and add them together, you would get that big angle again. So another thing to note is that if JKL is a straight angle, we're talking about this picture down here now, JKL, if it's a straight angle, meaning that it's 180 degrees, and M is any point that is not on that line, so whether it's on this side, that's a horrible noise. I was going to say, when is he going to turn that? He's like just sitting there in his golf cart with that noise going on. So if that point is on the interior, whether it be on the bottom or the top, what happens is, if you notice, what we've done now is split up that 180 degrees into two separate parts, the part on the left and the part on the right. Not evenly. It's definitely not split evenly. This is a way bigger angle over here than is over here. But the one thing that I know is true, without even knowing those numbers right there, is that together those two things would equal 180 degrees because it's a straight angle. So a straight angle will have 180 degrees. On one side is an obtuse angle. On the other side is an acute angle. I don't know the numbers because I don't have anything to measure it right now, but I do know that together they'll equal 180 degrees, and that will always be true of straight angles. We cool so far? Yes, ma'am. Yeah, yep. I'll hit pause in the video for a minute and let everyone get caught up. All right, we good? Can I move on? Okay. Worst case scenario, it's going to be in the video. You could always catch up there. All right. So remember how we had those little red tick marks that show that two segments were congruent? Now we're going to have the same kind of thing, but with angles. So notice that little line there. In our notes, when things are actually like colorful notes, we will see that we tend to use this little red line to indicate that two things are congruent to each other. Oh, let me see. So you'll see that this angle right here has a red mark, and this one has the exact same red mark. That red mark indicates to you that these two angles are congruent. Now, what did that word congruent mean? Same shape and same size. Even if they're pointing different directions, like think about it, like if I have two toys, right? I buy them at the store and I chuck them across the room and they land in different positions, are they still the same size? Assuming they didn't break.
Yeah.
Yeah, they're still the same size. They're just in different places. They're facing different directions. One's upside down. They're still the same. And so that's what we're saying is that angles can be exactly the same too. There might be multiple 90-degree angles in here. All those angles are congruent, but they're in different places. So that's what that red line means. And sometimes, like let's say that there's a bunch of angles. I could even have like a separate set of angles. So maybe I'm showing 4 angles at the same time. And I want to show that 2 of these match up and the other 2 match up. So I might use 2 lines. And it shows that the ones with 2 lines match the one with 2 lines, but the ones with 1 line match the other one with 1 line. We make them into like twins. They each have the same markings. And you could have 3 lines in there or 4 lines because you'll see that as we go on, these are going to get busy. There's going to be tons of angles everywhere, and they're going to be marked up with different things. But your job is to look at those 2 red lines and go, oh, wait a minute. So you're telling me that this is 40 degrees? Well, then without a doubt, I know exactly how many degrees B is. How many degrees is B? 40, because that little red mark there is a congruency mark saying it's the exact same angle. No problem. Yes, ma'am?
So in the examples you drew, you had 2 red lines. Is there a difference between having, oh, so 2 means they're not congruent?
Well, no, 2 means that what this meant right here is that the one that has 2 lines matches up with the one that is, imagine we had 2 sets of twins in here, right? We have 2 sets of twin girls in this classroom. Just so happens that, man, I had a weird semester where in one class I had 2 twin sisters and another set of twin sisters. There are 2 sets of twin sisters. It doesn't mean that all 4 of them match each other, right? I mean, they came from different families, they're different sisters and everything like that. So this indicates that like these 2 are a pair of twins because they match. They have the same amount of lines. Whereas these 2 are another pair of twins. You might even have 5 of them that have the exact same marking, which means all 5 of them are the same. So that marking tells you which ones go together. The single lines go with the single lines, the double lines go with the double lines. And what it means is that the measure of angle, this thing means right here, means the measure of angle A and the measure of angle B. It means their number values match. Not only are they the exact same angle, they look the same, everything the same about them, but what it means in true terms is that their number values, their degrees are exactly the same. So 40 degrees, 40 degrees. If one of them is 90 degrees, the other one's 90 degrees. If one of them is 179 degrees, the other one's 179 degrees. But I know this definitely couldn't be 179 degrees. I just made up that 40 degrees. How do I know that one of those are not 179 degrees? Yeah, these are acute angles. They're acute ones. They're the little ones. So it had to be something under 90. So again, we're going to use this congruency symbol with angles too. It's the same thing we learned with segments for those of you who are falling asleep on me. If your eyes are closed, hanging out at your desk, you might want to open them up before I have to come stand next to you, tap you on the shoulder, and wonder why your eyes are closed. All right, so that's what that congruency symbol means. It means their angles are exactly the same. Their numeric values are exactly the same. All right, this is what this might look like here. Now I'm going to clarify the picture before I get to this. There's a lot going on here, but this is not a lot. If you ask somebody who was in the 4th quarter of geometry, they would be like, bro, I wish things still look like that. That would be awesome. They don't anymore. So we've got some angles, a lot of angles going on here, and I'm going to clarify. They have a red line right here in between these 2 lines. So here's a ray, and here's a ray. And there is an angle congruency mark in between it. There is also a ray here, the same exact ray, and one here with the exact same marking in it right there. What does that mean about the green one and the black one?
They're congruent.
They're congruent, meaning that their number values are the same shape, same size, but whatever one of them is, the other one is too. And I'm going to show you in a minute that I actually know exactly what that number is without any special skills. You already there? Let me come back to you. If you know the answer, let me come back to it.
I know the answer, but the lines, they're not the same. Yeah, they're kind of different.
What do you mean?
Like from BEC, that line is different from AEB. The line inside. The red one. The little red one.
Let me erase. Oh yeah. So even though it's shaped differently, it's still just one line connecting them. So I see your point. He's saying that this looks different. He's saying that this looks different than that. So that'll happen sometimes. But what we really care about, there's one line and one line. If one of them here this would mean they were different. I'm going to draw something that this is not in your notes. Don't draw this. This would indicate that they were different. One of them has 1 bar. One of them has 2 bars. So that means they're different. But in this case, they each only had one, so that means that those two things are the same. Even if one is further out, so it looks a little bigger, you see one red mark and one red mark in there, those angles are the same. Even if like whoever drew it doesn't look the same, that's what you're telling me mathematically, that these are the same and I can go by that. Additionally, they drew one here to indicate that this is equally as long as this. Okay, so right there, point E, below that is equally the same as the point above that. So what do I know about point E? What is special about point E? It's a special kind of point if it's equally as far on the top and the bottom. Yes? It's a what? It's a midpoint. It has to be a midpoint because it's in the middle of those two things. So that line going vertically, that is the middle of that. Now check it out. If you kind of tilt your head to the side a little bit, turn it to the right, and like if you're like lying on a pillow and looking at it, like if you're turning your head to the right, if you notice that red line is a straight angle, right? If we only look at that red line, then it's 180 degrees from here to there. Would you agree if we're only looking at the red line? Okay, what does this box mean? It's a right angle, which means in plain English what? It's how many degrees? 90. So if this is 90 degrees, and that whole big rainbow thing there, that arch is 180 degrees, how many degrees must be on the other side? 90. There must be 90 on this side too. Now, I don't know how that's broken up, or do I? If this is 90 degrees, and those two parts of it are exactly the same, then how much must each of those be? 45. They have to be, because we took that 90-degree cheesecake there and split it right down the middle into even pieces. And if you take 90-degree cheesecake and split it right down the middle, then each person gets 45 degrees. So we learned so much just by looking at there that we've got congruent segments, we've got a right angle, we've got congruent angles. We can tell a lot of things with those. And that might be the kind of problem I give you and say, tell me the angle, the measure of that angle. When you see that M, it means the measure. What number is angle BEC? Well, BEC is one of those two pieces of cheesecake. It would be 45 degrees. All right, 2 more slides to go. We're almost finished. All right, remember when we've got this term that we call a bisector. When something is bisected, we talked about this when we looked at that skateboard problem. A bisector means something is cut exactly in half. It is the thing that cuts something in half. A bisector of an angle is a ray that divides the angle into two congruent angles. So for example, they are indicating here that BD is the angle bisector of ABC. So here's ABC. It's this big piece of cheesecake. And BD is the bisector of that. Here's BD, meaning it's splitting that angle perfectly into two pieces. So BD bisects that angle. Well, then that must mean that angle ABD, that's here, ABD is right here, is congruent to angle DBC, this one down here. So if I'm saying that those two angles are congruent, then they must have the exact same values. Well, luckily, they already wrote those numbers in for us. They said the one on top is 20, the one on bottom is 20. So here's the big question. How many degrees is angle ABC? The red one is 40. Angle ABC is 40. It's the 20 degrees on the bottom and the 20 degrees on the top. That must be 40. 20 plus 20 is 40. That's where these numbers are coming from. Again, think of it like cheesecake. It's been split up into two pieces. One of them is 20, one of them is 20. Put those 20s together, you got 40. So that word bisector, just get used to it. It is something that is splitting something else perfectly in two, right down the middle. Even, Steven, always one thing has exactly the same as the other. All right. So here's where we get tricky. Notice there's a hot mess of things going on there. Notice that I have numbers in there. Those numbers do not have degree symbols on them, so that does not mean how many degrees they are. It just is like how I showed in the first thing, is that there could be a number that represents that angle. So it says, give another name for each angle. And the first one they say is DEB. So here's how I'm going to draw it out. I want you to get in the habit of doing this. DEB. I just made those marks there, and I'm going to start from D, go up to E, and then down to B. So that's the angle I'm talking about right there. Notice I can even make it go further. That's the angle we're talking about right there. What is another name for that angle? Yes, ma'am. BED. We can reverse it. I could name it angle BED. Is there another name I could call that? What's that? I thought that was so great, except for I can't call that angle EY. I'm not allowed to call that one because there's another angle right next door to it that shares that E. So I'm not sure whether you're talking about the one on the right or left if you say angle E, or if you were talking about the big one. So angle E, not an option, but there is another name for that angle. Yes, sir. Not EDC, because if you say EDC, that means that we're not talking about this one right here. Yes, ma'am? Angle 4 is definitely, we can call that angle 4. There's a 4 there and it's not degrees, then we can definitely call it angle 4. Again, that doesn't refer to 4 degrees. It just means there's a whole bunch of angles on here and that's the 4th one on there. How about angle CBE? Watch as I'm going to do this every single time. CBE. Here's C, here's B, here's E. I'm going to play connect the dots in that same order so that I can see exactly which one I'm referring to. So now I'm talking about that red one down there. What's another name for CBE? I could reverse it. EBC. That's an easy way to do it. Is there a number I can use for it? Angle 8. Notice 8 is the one that's like hidden right in there, in between those two lines. It's between there as if it's about to get eaten by those red lines. That's that angle. I'm going to go to angle BEA. Here is BEA. Notice that all I have to do is connect the dots now. Sometimes it's hard to know what they're talking about unless, this is where the colored pencils help so much. But if you're doing your homework on here, it's fine. But if you were doing this on a test, you might want colored pencils. Another name for angle BEA? AEB. AEB, reverse it. Another name for angle BEA is what? Yes, ma'am?
Angle 3.
Angle 3. How about this? Tell me why I'm lying to you. How about I just call that angle E? Why not? It's got a vertex at E. Why can't I call it angle E? Because there's another one there. So it's hard to differentiate whether we're talking about 3 or 4 or the big one that wraps around 3 and 4. So that's not a good name for it. How about angle DAB? I'll dab to that. Let's see. DAB is right here. DAB. So I'm going to play connect the dots in that exact order. DAB. Yes, sir. You had a name for it?
I was going to ask a question for number 3. You call it angle 3. Why can't you call it angle 2?
Because, so see where those two rays meet? It's where they meet. That's like, so when we're looking at the blue one for number 3, look where the two lines meet up. That's the number we can use to do it, like right where they meet up. So like that's the number that, not 2 because it's touching only one part of there. We want the number in between the two lines, like 3 is about to get chomped by those blue lines. So let's talk again, let's go back to the yellow one there, angle DAB. Yes, sir?
Angle DAB.
All right, that's an angle that's totally bad. Oh, math jokes, you're so funny. Thanks for the pity laugh, I'll take that. All right, what else? What's another name? Yes, ma'am? Angle 1. Now, they won't always have numbers. If they don't have numbers, don't introduce your own numbers. You don't get to do that. You are interpreting what's already there. Now we go on to angle 7. So I'm not going to color code anymore because I'm running out of color. So you're just going to look at this. And if you want to look at yours, what is another name for angle 7? Yes, ma'am?
DCB.
D, she chose D, C, B, which is great because those wrap right around angle 7. Notice it's just about to, if you wanted to call that BCE, you could even use E up there. As long as it made two rays that meet up at angle 7, then fantastic. But I'm going to use the one she chose. There's probably a bunch more. I'm not going to keep naming all of them. We're just going to give the ones that we've got here. Somebody different, give me one for angle 9. Yes, sir.
Oh, I thought we were still doing ones for 5.
No, we're going to keep doing, like, we're only going to do one for each now.
Okay. 6. Wait, no, that's 9.
For number 6, yeah, number 6 is angle 9. What's another name for angle 9?
ABE.
ABE is fantastic. Here we go. ABE, those wrap right around angle 9 as if they're just about to get pinched right in between those two lines. So angle ABE. There are other names. We could go on a lot of these names, but I'm not going to do every single name for them because I want to get us out of here in time. How about this? The measure of angle 1 plus the measure of angle 2 will equal what angle? Meaning if I took those two pieces of cheesecake, angle 1 and angle 2, and I smashed them together, which angle would I be talking about? Yes, sir.
Well,
Not, so I couldn't call it A.
EAB.
Okay, so here's what we're talking about. If I took angle 1 and added angle 2, and I'm sorry, what angle did you say?
EAB.
EAB would certainly be it. It would be those two cheesecakes put back together. That's it. So angle EAB. Now we're going to do the same thing for 3 and 4. 3 and 4 are two smaller pieces of cheesecake. If I were to take them and add them together, which larger angle would I get? Sir?
AED.
AED is fantastic. You could have said AEC, you could have said other letters, but AED is beautiful. AED wraps right around 3 and 4 there. So angle AED. You don't worry about, as long as yours, you could have different letters there, I will do the interpreting. This is the part where I go, okay, let me interpret your answers. Last but not least, we've got angles 5 and 6. Yes, ma'am?
Angle EDC.
Beautiful. And that's the one that people sometimes struggle with here, because if you notice, here's angle 5, here's angle 6 right there. Those two together would be EDC, a straight angle. It goes all the way from here, all the way over there. EDC is great. It could have been CDE. Fantastic. So this is our last slide, but it very much expects something like that. That's where we're headed. That's where this is going to start getting more and more complicated. We're going to start seeing pictures and being able to pull out little parts of them. So the angle addition postulate talks about that one big angle split into two smaller angles. If we were to go, and here, let's look at this in another way. Actually, let me add one more thing that's not in here. Let's say that this whole angle here is 80 degrees. Okay, that's an 80-degree angle. And this part right here, I'm just going to make something up. This angle right here is 20 degrees. How much is this part right there? I heard some different numbers. Yes, sir?
60.
It has to be 60, because remember, the big piece of cheesecake we said is 80 degrees. It's the whole thing. So 20 plus something else must equal 80. That something else would have to be 60. That's how the angle addition postulate works. The two parts make up the whole, just like it did with the segment addition postulate.